All right, so now we're going to look at two kind of basic rational functions. First, we've got y equals 1 over x, and of course you could pull this up in your graphing calculator if you're not staring at a graph already. So y equals 1 over x looks something like this. Just a couple of notes that I wrote over here. It's the same as f of x equals 1 over x. That would be in function notation. And if you evaluate f of negative x, you'll see that that's equal to negative f of x. So this is an odd function with origin symmetry. So you can see that graphically for every xy, there's a matching negative x, negative y. The vertical asymptote is x equals 0. So x equals 0 is the vertical asymptote. We could draw that as a dashed vertical line here. And the horizontal asymptote is y equals 0. And I could represent that with another dashed horizontal line. Okay, so we can see this visually. Also, we could do this algebraically. Setting the denominator equal to 0 gives me x equals 0 for my vertical asymptote. For horizontal asymptote, degree 0 numerator over degree 1 denominator. That's bottom heavy, so that's why we end up with y equals 0. And I just want to point out that if I use the trace function, if I plug in x equals 1, I get y equals 1. Right, so there's the ordered pair 1, 1. And if I plug in x equals negative 1, then that gives me y equals negative 1. So I kind of use these as reference points. So what we're going to be doing is shifting these basic graphs, both this function and the function to the right. We'll be shifting them around. And I kind of think of these reference points relative to this origin. In this case, it's literally the origin 0, 0. But as we start shifting our graphs around, wherever my vertical and horizontal asymptotes intersect each other, I kind of treat that as my new shifted origin. And from that origin, I'm going to go to the right one, up one, to the left one, and down one to plot these two reference points and then skate along my horizontal and vertical asymptotes. Okay, let's take a quick peek at y equals 1 over x squared. Same as f of x equals 1 over x squared in function notation. And if you evaluate f of negative x, you'll find that it equals f of x. This is an even function with y-axis symmetry. And you can pull this up in your graphing calculator, 1 over x squared, if you don't have a picture already drawn. So your vertical asymptote for this function, again, would be x equals 0. Setting the denominator x squared equal to 0 gives you the solution x equals 0. So that's my vertical asymptote. And then my horizontal asymptote, again, it's a bottom heavy function, degree 0 over degree 2. So horizontal asymptote y equals 0. And again, if I want to identify some reference points using the trace function, I have the ordered pair 1, 1. And then by y-axis symmetry, I know I'll also have the matching ordered pair negative 1, 1. Negative 1, 1. So again, I'm going to kind of think of this origin, which is literally the origin here. As I shift these asymptotes around, wherever they intersect, that's going to be my shifted origin. And then to get to my reference points, I'll go to the right one, up one, and to the left one and up one. Okay, so here's what we're going to be doing with these graphs. In numbers 9 and 10, the basic graphs above have been shifted. Determine the following. So first, for number 9, I just want to see which of those functions above number 9 resembles. And it's looking like a nice copy of y equals 1 over x, right? Y equals 1 over x, just shift it around. So it resembles y equals 1 over x because we've got part of the function up in the top right, part of the function in the bottom left. Okay. All right, where for number 10, if I want to figure out which one it resembles, that more resembles y equals 1 over x squared, right? Because I've got the function in the top right and in the top left, and nothing below that horizontal axis. So this one resembles y equals 1 over x squared. Okay, so we're going to think of these in terms of shifts. So for number 9, focusing on that for right now, you can complete these in any order that you want. For me, I find it easier to start with the vertical and horizontal asymptotes and work from there. So I can see that my vertical asymptote occurs at x equals 3. And my horizontal asymptote is at y equals -2. So this allows me to determine my shift. X equals 3 puts me to the right 3. And then my horizontal asymptote y equals -2 means I also shifted down 2 from that original y equals 1 over x function. So if I were to write out my equation, so the basic form is 1 over x, right? To account for that shift to the right 3, that's going to occur with my x. Remember, horizontal shifts come from my x. Right 3 comes from an x minus 3 in the denominator. And I don't need to draw parentheses because it's the only factor in that entire denominator. So just make sure the fraction bar goes all the way over the x minus 3. And then down 2, that vertical shift, I can just tack that onto the end of my function as a -2. So y equals 1 over x minus 3 and then -2. And let's go ahead and check it in our calculator to make sure we got that right. So 1 over parentheses x minus 3, close the parentheses, so that's my denominator, and then -2. And it looks like we have a match. Okay. And I just want to point out before we move on, so this is my fake origin here over at 3, -2. So notice that this passes through the reference point if I go to the right to 4, and then if I go up, passes through 4, -1. 4, -1. And I can also go to the left 1 and then down 1. So to the left 1 and then down 1. So that puts me at 2, -3. Okay, moving on to number 10. So first I'm going to identify my vertical and horizontal asymptotes. Vertical asymptote is at x equals -2. And it looks like my horizontal asymptote stays at y equals 0. So my shift is just to the left 2. There's no vertical shift. So my original equation is y equals 1 over x squared. To account for that shift to the left 2, I'm going to have x plus 2 in parentheses and then squared. So y equals 1 over x plus 2 squared. Let's just double check that. 1 over x plus 2, close the parentheses, squared. And it looks like we have another match. Okay, number 11, use one of the new basic graphs to help you sketch the following. So y equals 1 over x plus 5 and then plus 2. This resembles y equals 1 over x. And this is my function where it appears in the top right and the bottom left. Sorry, that's a terrible sketch, but this one that we saw on the top left here, 1 over x. So 1 over x plus 5 would bring us to the left 5, and then the plus 2 is going to bring us up 2. So first I'm going to sketch my vertical asymptotes. So now my vertical asymptote is going to be at x equals -5. So my vertical asymptote is at x equals -5, moving me to the left 5. My horizontal asymptote will now be at y equals 2. So HA, horizontal asymptote, y equals 2. All right, so -5, 2 is kind of acting as my new origin. So I can go from -5 and then 2. I can go to the right 1 to -4 and then up 1 to 3. I can also go to the left 1 to -6 and then down 1 to +1. And then I'll just draw this skating along my asymptotes. So I use that as a reference point to go ahead and sketch my graph. All right, for equation in B, y equals 1 over x minus 5 squared minus 3. This one is going to resemble y equals 1 over x squared. So that's my function that looks like that. Quick and dirty sketch there. Okay, so as far as my shifts, x minus 5 will push me to the right 5. The minus 3 will push me down 3. So to the right 5, here's my vertical asymptote. So there's my vertical asymptote, x equals 5. And then my horizontal asymptote going down 3 puts me at y equals negative 3. All right, let me just redraw that portion. It looks a little weird. Okay, so I've got my new kind of fake origin here at 5, negative 3. And now from that, I'm going to go to the right one and up 1. And then I'll go to the left one and up 1. So these give me new reference points. And then I draw the rest of my function just skating along these asymptotes here. Just a little bit. There. Looks a little bit better. Okay, so there's a sketch of my new graph, my vertical and horizontal asymptote, and then using those reference points to guide me as I skate along my asymptotes.